Hello, everybody. Welcome to the KubeVirt weekly community meeting. I'm your host, Chris Caligari, and let's begin. I think I wanted to add just a quick bullet point to see if there's anybody new that would like to introduce themselves. I know we have a couple of new folks on the GitHub repos. I don't know if they decided to join us this week. So going once, going twice. No new introductions. Okay.
Well, okay, I could do a quick intro. My name's Chandler Wilkerson. Hello, everybody. I've had this meeting on my calendar probably for a few weeks since I started working with OpenShift virtualization on the Red Hat side, and just kind of tuning into the community to see what's going on.
Hey, Chandler. Excellent. Thanks for joining us.
Yeah, and feel free to add things to the agenda, or if you had anything you're just curious about. This is a great forum to just bring up pretty much anything that you want attention with Kubernetes or KubeVirt.
And the link to that shared document is in chat. You will have to be a member of the KubeVirt develop team or a develop mailing list to get edit access. Otherwise, you have read-only. And I should say, Chandler is my new teammate, so we will be working together, and he'll be backing me up for community duties, hopefully, in the near future. Okay, let's move on to the agenda. We have R. Hallisey.
Hey, sure, yeah, so I have the first item. I'll share my screen here. Walk through some of what I'm looking at. Okay, you should see my Firefox window with the meeting. So I have, so this is a topic that was brought up at KubeVirt Summit a few weeks ago, and I just kind of wanted to spend a few minutes talking a little bit about I put a little bit more thought into some of the, after coming away from the discussion and captured that in the doc there. So if you wanted to check out the summit session, there's a link to it here, and then the doc with is the second link for some of what we'll be looking at. So all right, I'm gonna go to the doc now. I'll leave folks, you know, if you want to read a little bit more of the problem statement, it's here. But basically, at a high level, just to introduce this topic for folks who don't know what I'm talking about. So KubeVirt Bulk VM API. So I'll just kind of highlight this with like a few features. So like the idea is that you could have, there could be an API in KubeVirt that I can have a single API call to launch many VMs, like for example, I say hundreds of virtual machines. And the idea would be we can have things like different virtual machine profiles. And I have another name for the third item called pet scaling. So like granular control of specific VM count. And then this idea of pool refresh, which is deleting virtual machines and then having them refresh in the VM pool. So kind of extending on what was the feedback from KubeVirt Summit, which is sort of the idea of a virtual machine pool. I talked about it as sort of in the context of a job, which sort of captures the first item. And so I've added these three sort of as fit more into the idea of a pool. And particularly, I talk about in like the problem statement, how these kind of extend Kubernetes concepts in a different way. Like I said, first one being a kind of like a job, pet scaling, kind of like a pet set. So like things go up and down in a sort of an order. VM profiles, this is a little bit different. I mean, this is kind of like templating and sort of mixing different virtual machines together. And then lastly, like a pool refresh, which would be kind of like a replica set. So kind of combining a bunch of different concepts together to create kind of this API. So this is kind of what I had in mind. And so I really wanted to just spend a few minutes introducing it and gathering some feedback. So let me talk one more thing about the use case, and I think that can help too. So one idea, I'll just kind of read this. So if I have a virtual machine pool, so it has all 4 features that I illustrated above. I have 2 VM types: a 50 gigabyte mem, 2 terabyte disk virtual machine A, and a 5 gigabyte mem, 1 terabyte disk. That's virtual machine B. If I can request 20 of these A VMs and 10 of these B VMs for a total of 30 virtual machines. And what I can do with it would be like I'd be able to delete a specific A VM, A type VM, and the pool would be refilled with a new A type virtual machine. I could scale down the number of A type VMs, and they'll have some sort of priority ordering. So it's kind of like the pet scaling. And I could scale down 20 of these 20 virtual machines, and there'll be some sort of priority list. So like that's just a generic, like at a high level, maybe that ends up being 5 A's and 15 B's or something like that. So those are kind of like, that's an example of how this would look. And then from last time, I originally had just Amazon Fleet as an example. And there was another one, someone pointed out that Azure VM scale sets actually is also very similar to this. So there's some prior art here. So I just kind of want to get some feedback. What do folks think? What's their general reaction to like when I talk about some of these concepts?
I'm trying to understand the difference between, I'm sorry, I know we went over this just for, just to kind of bring context back. What was the difference between this and the virtual machine instance replica set that we have today? Like what's like the core differences that we're looking at here?
Okay, so the so virtual machine instance replica set, I can only have one type of virtual machine, right? I can only scale up a single type of the virtual machine, and I don't have the ability to say to, let's say, remove, like if I scale down, I don't have the ability to remove like say a specific, like I don't have control over the delete, like what gets deleted. There's no, we don't care. Like it, you know, the API doesn't care.
Okay, and for scale down using this pool concept, how would you anticipate this priority ordering working? We're talking about one that's been online the longest. Would there be different strategies? Maybe ones that are marked can be scaled down, or how would it?
Yeah, so I haven't specifically laid them out here. I'm talking very generic. So it could be all of those things. It could be any like length, yeah, like the longest time running, some sort of priority marking, yeah, like labels or something. Any of those concepts I think are totally in play.
Yeah, and I like that. I like that idea a lot. And to get the point of a virtual machine pool being able to control 2 different types or multiple types of virtual machines, why would that be beneficial over just having 2 virtual machine pools?
So it's certainly certainly an idea. Like, yeah, we could have 2 virtual machines pools. I just didn't think, I sort of wanted to try and capture like the whole idea within the API. So so for example, precisely what you said, this is feature 2 here. And so the idea was that I could capture this whole thing within the pool. So I can have, I guess I would say, I have the API be a little bit more involved, or a little bit more, or do a little bit more, I guess. Like because you could technically do it as 2 different pools, but I think that it could better solve the problem, because I would just be automating two pools, right? Which is kind of like what I wanted to capture in a single API, or have automation or wrapping around two pools.
Yeah, I'd have to see the user stories and understand the operational benefits of that to really be able to wrap my head around how that's helpful. So maybe that's something that like we can, maybe that's something you can shore up a little bit more in the document, even like under you, maybe you already have. I'm sorry, I haven't looked.
No, I haven't. So I think
okay.
I think I'm trying to go I'm trying to keep it a little bit high level. So so I can get like where I need to explain more. So that's a good one. And that's one I can expand on more.
Brian, would you also be adding like a scheduling hints, whether all of these machines has to be scheduling on this as close as possible on a single node, or like they have to be as spread as possible?
So that's I think that could be an implementation detail of this. Like I think that's a possibility, like to have scheduling hints as part of this. I'm trying to think where it would go, or if it's something that would be exposed at the API level. I'm not sure it would.
It's just some of the projects they use this notion of a pool or bulk scheduling of VMs in order to have an application that either has to be on the same as close as possible, or as spread as possible, because if one of the instances of the application is died, like it is going to die, then they will have a quorum or something like that. So I mean, usually this has been done with this logic in mind.
Okay, so scheduler hints, I can have something I look at too. Okay.
Yeah, that makes sense. I've seen that. Yeah. So if it's for resiliency, I guess it's kind of like anti-affinity rules, where say you had a clustering app and you wanted to guarantee that it could survive a node failure, then you'd want to have an anti-affinity rule to ensure that it's spread across multiple nodes. Okay. And then the other use cases, I don't even know how you would achieve the one I'm about to say. Sometimes people want to bin pack all their virtual machines or applications or whatever on one node at a time. Like it's pack this node as much as possible before moving on to the next one and stuff like that. But we're a little bit limited in what Kubernetes is capable of when we get to that sort of use case. This makes a lot of sense to me where you're going with this, Ryan. The only thing that sticks out to me is the different VM profiles. That's the only thing that of everything you've said that I have to wrap my head around. Everything else, as far as what I've thought about in the future for a virtual machine pool, totally aligns with what you're saying. And I really like the idea of priority lists for figuring out some sort of strategy for how we actually want to scale down, because that's one of the biggest things. Scale down is the hardest thing, really, when we talk about stateful workloads, because they actually matter. But the actual, like, this is kind of a pet pool, like you said, where each one of these instances matter to some degree.
Yeah. Okay. So I'll expand on this. I think so. One of my motivations behind it, like, was getting some inspiration from these two. Like, they both have it, so maybe I can see if I can find some more of like a little bit more about motivation there. Because I mean, I can kind of think at the same time, like I understand what you're saying. Like, we can just have two.
Or
so yeah,
here's a crazy idea. I mean, Kubernetes is built on this concept of layering APIs. It's possible, I'm getting ahead of myself a little bit, that you might have the virtual machine pool, and then you might have a virtual machine fleet that manages multiple pools in the future, or something like that. So you'd have, I mean, that kind of falls in line with it. For example, you have pods, you have replica sets, and then you have deployments that can manage rolling over and managing essentially multiple replica sets at the same time. But it's not exactly a perfect analogy to this, but that is the kind of layering effect that we see.
Yeah. Okay. Yeah, I like that. I like how you're looking at it like that. Okay. That makes sense to me. Because that ultimately I think would get to like what I'm after, which is like, okay, because like ultimately what the motivation behind the API is, like we're doing, like there's like, you're just doing a lot of API calls, and it's and then you're wrapping a lot of this stuff. And at least like these three, like are definitely, yeah, they can definitely go together. I could see this possibly going together, but yeah, I see what you're saying. Like this could also be an abstraction above these three.
Yeah,
You know?
I really like it. I hope you guys make progress on this soon. I want to see it.
Okay.
This is Chris.
Yeah. Hey.
Oh, sorry, guys.
No, go ahead.
I like this too. And as soon as I read that high-level feature set, my eyes starred up. I've got two colleagues at NASA and Lawrence Livermore National Laboratories that run a staggering amount of virtual machines on large x86 64 hardware. And they basically rent out compute to various National Science Foundation sub-projects. So when I say a staggering amount of virtual machines, they're running something like 50 to 100,000 virtual machines. It's just, their scale is incredible. And they have a lot of problems with deploying their various fleets. They try and execute things off their laptops, and then a network blip knocks out their Ansible playbook. So I definitely see great use for this in the HPC world. In fact, I may share this doc out to those my colleagues, if you don't mind, see if this is something they would be interested in.
Sure. Okay, cool.
Yeah, I'd love to get one of those research labs as, as one of our consumers. That would be a huge win for the validity of KubeVirt, but also just getting that kind of experience fed back into the project would be.
Now that you mention it, maybe I'll drag them into our weekly meeting just to talk. They are about to embark on a hybrid solution between legacy virtual machines and container workloads. And their entire organization is split between the two paradigms. And he's stuck in the middle trying to balance it all.
Do you know what, are they using something open source right now? Like
they're on Community OpenStack.
Okay, that's what I thought. That makes sense.
I'll take a note of that and see if I can get them to come in and talk to us in the next couple of weeks.
So one thing I remember from the KubeVirt Summit when this was brought up is somebody mentioned an interesting feature I don't think you've maybe captured here, where they may want to have a pool of game servers or a pool of desktops for a VDI kind of, virtual desktop infrastructure kind of thing, and have the ability to then detach VMs from the pool so they are no longer managed by the pool, and then have that replaced in the back end. And so essentially you have somebody comes in, wants a desktop and can be handed one that's already running immediately, and then they get to own that pet desktop from then on, rather than have it treated as cattle and taken down or scaled.
Okay. Yeah, so yeah, I think like that concept would fall under the idea of deleting, but I guess I could detach is sort of another verb that could happen here. I think because I think both those cases would essentially trigger a pool refresh. If that makes sense.
Mm-hmm.
Yeah, I definitely like to see detach is considered possibly a separate thing. Okay, you have deleting / detach. All right, that's good. The idea of detaching could mean two things. It can mean automatically scale down. So that could be part of the way scale down occurs, is you detach the virtual machine from the pool, which automatically deprecates the pool size. And then at that point, whoever detached it or whatever automation detached it decides how to shut it down or what to do next.
So if I do it in the way you're saying scaling, to me that sounds like two actions. Like I am like I'm scaling down by detaching. Like I'd have to, like, if this was a feature in the API, I would be like, okay, I'm going, or even this in this example, I'd be like, I want one less A, but instead of deleting it, it's detaching. So it's like another form of scale down, right? Like
it would be scaling down rather than declaring. This is kind of weird. I've seen this pattern used though. Scaling down rather than going to the virtual machine pool and deprecating a replica count, you would actually invoke some sort of action to detach a virtual machine from that pool, which would, and it would essentially say, all right, since this is being detached in this way, now we only want n-1 replicas. Like we're considering that a scale down action.
okay, so this is kind of like a new verb, I guess, in the, like there's no Kubernetes equivalent here. So this is kind of like this is very specific to virtual machines, and yeah. So like I think there maybe does need to be a separate section for this, but this is like yeah, I mean this would be like a whole section I could outline just on detach. I mean, this is because you know what I mean. Like it's very specific. It's totally different than delete. Like it's like deleting is detach is for in a Kubernetes. Deleting is not.
Yeah, and detach means something different. Like deleting means you probably want it to be replaced. I think that's what I'm going with. Detach means I'm purposely taking this thing out, and I don't necessarily want it replaced. Maybe I do, maybe I don't. I don't know. It's something for us to kind of think about, or at least let's kind of get the use cases for why we would detach and what the expected outcome of detaching is.
Okay. Yeah, I can add something for detaching. We can kind of, yeah. I mean, I could see it being a whole feature here. It may even be something that is on top of this. Like maybe we start with delete, and detach could be something that you can do with your scaling and your pull refresh or something.
Sure.
Okay. Yeah, I'll make a section for it just so we have it down. Okay.
This is good. I think we'll probably during these discussions we'll talk about some pretty advanced stuff. I think when it actually comes to implementing this, we need to boil it down to what's the most achievable initial iteration of this that we can execute on.
Yeah.
So
yeah, I've been trying to. So I've been. That was another topic. I wasn't sure I was actually going to mention here, but like this. So I think like this one to me seems to be like the simplest thing because it's like it's kind of already exists, like with the replica sets technically implements this, just it's not like sort of exposed in the sense that I'm asking about it here. So this would be, I think, one that would be good to have first. And then these and then like you talking about the priority stuff, I could see that being its own set of patches, and then having to do, so the idea of pull refresh and the priority would be part of tight scaling. So yeah, I mean that's kind of why I'm breaking them down here, because I think each of these would be their own individual features.
Sure. I think that API is the first thing to start with, just the virtual machine pool API. And I think the thing I really like about this is you get a lot more power once we pull in the replication to the virtual machine layer rather than the virtual machine instance layer. So there's persistence about that, and it also allows, like you said, or like you have outlined here, the pet scaling, which is a critical component here. Okay.
Yeah, and so the and so I guess then my next question. So when I'm talking about VMs here, now if I am scaling virtual machines and I'm and let's say they're running, like what's like this is sort of like we talked about this at save and restore. It's kind of the same idea, right? Like we would just have like like if I'm scaling up or I'm creating hundreds of virtual machines, I can also specify they be running.
Yep. That's another thing that's a detail. We'd have to discuss, does a virtual machine that exists but is set to not be running, does it count towards the pool or not? Like I think it would, but maybe those are different rules. I don't know.
Yeah, yeah. So like, what does the pool define? Yeah, is it a number of running or not, or is it a virtual machine object?
Maybe both. Maybe
Yeah,
all
maybe
the
both.
above. We'll see.
Okay, that's another thing I need to explore in this. Okay. I think I've got a number of things that are helpful that I can expand on. So, are there any other comments before I turn it back over? Okay.
Okay. Sounds good. Looks like a great new feature. Thank you for sharing that with us.
Welcome.
Okay, next on the agenda is an item that I brought up. I just wanted to make a quick mention that we are finally finished with the migration for user guide from the Docsify Markdown engine to the Make Docs Markdown engine. If you guys want to go and take a tour on your own and click around, please do so. There's lots of neat little features that have been implemented. We've also got a new development guide, and that's just in the GitHub repo README. And there's still some things that we need to tweak. The URI on the main KubeVirt.io website might need to be tweaked. It's currently set to /docs. I've noticed some search engine weirdness when we search for things related to KubeVirt. The URIs don't quite match up, so I need to get that fixed, and then some cleanup to the README file and tooling still needs to happen. But we're 98% complete, and I hope everybody enjoys our new documentation engine.
Yeah, I used it yesterday or the day before, doing some dev there. It's really slick, like just doing development and being able to preview things. So if anyone's approaching this for the first time, it's really like it's all documented how to do this. But I want to say I really appreciate the fact that I could preview what it was going to look like exactly locally, really easily. That just was one command to run, like make run. I think that's all it was. And then when I am looking at that website, if I save in my editor, it immediately refreshes in the web browser. So I immediately see that change, like instantaneous. It's pretty remarkable. I like it a lot. It's a really efficient way of doing development for the user guide. So thank you. I really appreciate it.
You're welcome. Okay, next, updating CRD to V1.
So hi everyone. I'm Antonio. So I'm working on pull request. I'll just paste in the chat this one. So basically, it's about migrating all the references that we have in KubeVirt from V1 Beta 1 to V1. Since it's getting removed from Kubernetes, I think from 1.23. And thing is, now in CRD we have multiple, previously in V1 Beta 1, you would specify the validation schema just once per CRD. Now you have to specify the validation schema per each version, and we have two in KubeVirt. And that makes the config map that we push for the install strategy just too big. It becomes bigger than 1 megabyte. And as such, it's impossible to install KubeVirt. The kind of simple solution, quick but not too dirty, solution that I implemented was to compress the manifest that we have in the config map and code them in base 64 and push the config map as such, which as the makes the config map 160 kilobytes. So it's good to go for Kubernetes, but it makes it unreadable from if you just get the config map as a user, it makes it unreadable. You would have to uncompress it and decode it. So yeah, just a shout out if anyone else has a better idea, or if you think this is an acceptable solution. So yeah, thoughts.
Which config map are you talking about? I'm not completely following.
So the Virt operator, so I'm pretty new to the project, so I'll try explaining, but so when the Virt operator starts off, it pushes this install strategy config map, which contains all the manifests that we generate. So all the CRTs that KubeVirt is going to, yeah, so that config map. So that gets too big.
Wow. Okay. All right.
Yeah.
That's surprising. Goodness. Okay. So that's an internal config map that's just consumed by us. Yeah, we can compress it. We have complete control. We can compress it. It's just very surprising that we actually. That's nuts. Huh.
Yeah, we were thinking together with Ashley. There are different roads that you can go down to, like I don't know, move to a file-based thing instead of a config map, but you would have to mount the volume in every pod, and you have to manage this volume somehow. It gets more complicated. Or to split the config map, so like one config map per CRT. But compressing, to me, seemed the most straightforward thing to do, and it's also like a 20-line commit, so it was very easy to implement.
How much is it compressed? So let's say I guess I'm trying to understand how far over are we on the 1 megabyte limit, and with compression, how far under do we get?
So without compression, we're at 1.2 megabytes, more or less. With compression, we are at 160 kilobytes. So we have a lot of room for future developments. We should be good for a long time, or maybe forever. I can't answer that.
Okay, that would be my preference. I think you're on the right track. Yeah.
Okay.
Yep. And so we need to support both at the same time. The ability to compress this install strategy into a config map, and then at the same time, our operator would have to understand when that config map the contents are compressed and when they're not. So there might be at least some over. Yeah. Okay. So you probably get it. We just have to put like a label or annotation to indicate, or maybe even something in the config map itself to indicate that it's compressed or not, so we know how to operate with it.
Yeah, I actually didn't think about that, but I guess I can just add a label to kind of tell if it's being compressed or not.
Sure.
Okay,
yeah,
thank you.
Makes total sense.
Okay, very nice. Another really, really good feature. Next up, KubeVirt config set on text fixtures.
Hi. So it's more of a question. In our end-to-end test, we are the setup of the test are setting the feature gates, some static feature gates on or off statically, and it saves first if I understood correctly the code, it saves first the original configuration of the cluster, and then of KubeVirt, and then it restores it back when the tests are finished. All the tests are finished. My question is, how I mean, I was surprised because I don't understand how are we supposed to run it on conformance test or on clusters that are not exactly our regular KubeVirt CI. Is there like a workaround on how to you enable this or control this from outside the tests? That's my main question.
I don't know if anyone who works in QE for KubeVirt in any capacity is on. I'll answer the best to my understanding. We have an option to skip the setup of our feature gates, I believe, where essentially it's assumed that everything is set the way you want to test it in the environment before we start. And I believe that's how it's possible to test it without mutating necessarily as a setup criteria, how KubeVirt's configured. Does that answer
yes,
what you were looking for?
Yes, I guess if it's like configurable, this is what I was missing. I could not understand if this is really configurable because I just see that it's just populated in a config and that's and then applied. That's it. I didn't see it any, but maybe I missed it. I cannot say for sure. And yeah, that's one part. And the second part is we are not supposed to restore in the middle of the test. This is the second question regarding this. We are not supposed to restore in the middle of our test the original configuration, right? Because I saw one instance of that, which a bit worried me. Do you know?
It's complicated.
Okay.
It's well, okay. So here's the issue here. As part of our test suite, where we are testing the operator itself, and to do that, we are actually doing things like deleting the existing Kubernetes install and then restoring it after we're done. If we're going to test those workflows, there's not a great way of doing that other than capturing the initial state of the KubeVirt custom resource, performing whatever our test needs to do with the operator, and then restoring it after that test is complete. So I think that's probably what you're seeing.
So I'm seeing actually in a lifecycle test, a VMI lifecycle test that on a tear down operation, it restores the original in one place. It's for one specific test. I can put a link to the PR, so that's the best I can do here, and it just restores it. This is the PR. I mean, I try to change it, but it doesn't work. I try to change it to restore it to the default KubeVirt one that is supposed to be set, but it will not. It doesn't work. Something is better. But I just found it very odd that we do restoration of the original in the middle, and we don't know which is the next test that would run. So it may just be like that, left like that.
Oh, well, the after condition should restore it. I guess I don't quite understand what your concern is. It should be, everything should be in a consistent state before the next test runs.
So I'm saying that the current, there is one place in the test that is doing restore KubeVirt resource, which is restoring, in the end, it restores the configuration before the test even started, like the original configuration. Then this is in after each close.
Yeah, I see it. I'm looking at the VMI lifecycle test.
Yeah. So this is why I found it very odd, because if we in the middle we restore something that is not what we set, this is that was strange. But yeah, but that's it.
You say restore something we didn't set.
Yeah, the restore KubeVirt resources is restoring when there is a setup in the test before it's part of the test setup of all the test setup, and there you read the current configurations, place it in a global, and you are supposed to restore it after all the tests are gone, so you will leave the cluster in the original state. But here we restore it in the middle of the test, and we erase all what we did in this is what I'm saying.
Yeah, that makes a lot of sense.
But it doesn't work. I mean, my attempt to fix it doesn't work. It's like something is odd there.
Yeah, you're completely right. I have no idea how this even works, because we're copying that original config before we set the feature gates or anything. Okay.
So if anyone has any ideas, I will be glad to hear something. But I will try to investigate it myself. But I just try to check if maybe I'm missing some basic information here.
For those playing at home, what's being referred to as the original config in this case is before the test suite's run and before we add our feature gates and the things we need. That's what it's restoring to in the middle of the test suite run, which is probably
yes. But it is wrong. But it's the only it is wrong. But this is the only if you do that the execution of the loop that you see after, we wait for some state, that only succeeds when you do that. so
my guess is we've gotten very lucky, and that when we've restored this, because of the ordering that the tests have occurred in or something like that, it hasn't collided with any of those feature gates that we need. The other case, the environment already has everything we needed before it started.
Yeah, so there is one thing wrong. There is one thing that is you could say that you may be lucky, is that when we start a setup before each, there is a before each that always tries to set the config default. It tries to set the original default config, or not original, the set test or default config. But I think it's not assured that everyone will do it, because maybe there are tests that don't want to call that. So anyway, yes, seems like we are lucky, but I'm more interested to understand why this is not working.
Yeah, absolutely. In fact, I don't know if I'd spend so much time trying to understand how, but I would just fix it. Like, this is obviously wrong. So I don't have any idea how we've made it this far with that. It's all just been luck.
Okay, thank you.
Okay, I think that brings us to the end of the official agenda and on to open floor topics. And Pep has the first open floor topic.
Yeah, just a quick one. Finally, the recording of the 20 sessions of the KubeVirt Summit is now public, just over the last hour. So you have the link in the meeting minutes. And I just wanted to take the opportunity to thank again, all the presenters, everyone who helped organize this, review the proposals, submitted proposals, anyone who attended. Thank you all. And you can now enjoy it again. If you missed it, well, watch what you missed. There's lots of good content. So just wanted to mention that. Thanks.
Thank you, Pep. And anything else for the open floor? Going once, twice, 3 times. Okay. I wanted to add a new section to talk about longstanding or important pull requests that are worthy of discussion. And I've got one that actually affects us all, and how we manage membership and upgrading members to becoming community managers and moderators and repo owners. If you've got any feelings about how that process is managed, please take a look at Community Poll 76. Very much welcome comments on that. I was really hoping to get this merged before KubeVirt Summit, but it didn't happen because of all kinds of different reasons. Mainly, I ended up in the hospital for 2 days and bed rest for 4. So that took a big chunk out of my time. So if anybody else has any pull requests that they'd like to bring to the community's attention, please add a note here and we can talk about it. Or at the very least, bring it to the attention of a reviewer. And the silence is deafening. So going once, going twice, and going 3 times. We'll move on to the bug scrub. Peter says he cannot attend this week, and so how about a volunteer to lead this section? And once again, silence.
Yeah. So we have 10 minutes left. I don't know. I can't share my screen or just because of I'm not. I'm on Wayland. I have to log out and log back in. Does anyone have any high priority issues they want to discuss? Maybe we can skip it this week. Is there anything I guess we should just bring to everyone's attention? I'll look at the list real quick and see if there's anything we should just bring up in this form. No, I'm not seeing that much. Is Alexander on the call? I can't see everyone. There is one for him specifically, but okay. I'll look through the first few items, maybe ping a few people, just so we can make a little bit of progress this week. But I don't think there's anything. We have a pretty small group today too, that's necessary to go over.
Okay, sounds good then. If there's nothing else, then we'll conclude this meeting. Thank you, everybody, and enjoy your week with KubeVirt.
All right.
Thanks.
See you later.
Bye.
Bye.